Hi dear students, this is the 9th part of the 5th module of the subject EST 100 Engineering Mechanics. In the last presentation we were discussing about the numericals problems from the topic general plane motion. This is actually the continuation of the last presentation, and we will continue with the numerical problems. The problem is a bar PQ of length 1 meter has its end P and Q constrained to move horizontally and vertically as shown in figure. The end P moves with a constant velocity of 5 meter per second horizontally. When the bar makes an angle of 30 degree with horizontal, find the angular velocity of the bar, the velocity of the end Q, and the velocity of the midpoint M. So in this problem, a bar is given. It is kept one end touching the floor and the one end touching the wall. This is the wall and this one is the floor. It is touching at point P in the floor and at Q at the wall. So considering the entire motion of this bar, you can see that if the P is moving, the possibility of P to move is along the horizontal surface towards the right. That velocity is given as 5 meter per second. So Vp, the linear velocity of the point P of this bar, is 5 meter per second, and it will be along the horizontal direction, and about the point Q it will be sliding over this vertical wall. So the velocity of the point Q, Vq, will be always in the downward direction along this vertical line. So Vq is in this direction and Vp is along this direction. So it is easy to identify the instantaneous center. Only thing what we have to do is draw the perpendicular from the point P to the velocity vector Vp. So it will be a vertical line. From Q, draw a perpendicular to the velocity vector Vq. So it will be a horizontal line. Both meeting point will be the instantaneous center. As you can see here, the horizontal line is drawn from Q perpendicular to this Vq, and perpendicular line is drawn to this velocity vector Vp. Also the meeting point is the instantaneous center I. Now about this entire link OP will be rotating about this instantaneous center. That is what is the meaning of the instantaneous center. Now from the basic definition, we know that the linear velocity V will be equal to R into angular velocity omega. V is equal to R omega. So talking about Vp will be R into actually radius will be radius will be the distance from the center of rotation to that particular point. Here it is IP. So Vp is equal to omega into IP. Similarly, Vq equal to omega into, here radius will be IQ. So you got two equations. One is Vp omega IP, then other one is Vq equal to omega I by IQ. Now dividing equation for Vq by Vp, we will get Vq by Vp equal to omega IQ divided by omega IP. Omega and omega will get cancelled. So finally you will get Vq by Vp equal to IQ by IP. Now considering this right triangle, you can see that IQ by IP. See in the problem it is given that the rod is making at an angle of 30 degree with the horizontal. At that instant we have to find out the velocity and all. So here this angle is 30 degree. Since it is 90 degree, so the remaining angle will be 60 degree. So we want to find IQ by IP. See from this figure, IQ is the opposite side for the angle 60 and IP is the adjacent side. Opposite by adjacent means it is tan of angle, so tan 60. So IQ by IP equal to tan 60. So VQ by VP equal to tan 60. VP value is given as 5 meter per second. So VQ can be identified, or VQ can be calculated as 8.66 meter per second. VQ equal to VP into tan 60. VP is 5. Tan 60 value you can get from the calculator. Now VQ value is 8.66 meter per second. Now we want to, our aim is, so we got the second part, VQ, the value of VQ we got. Now the first part is the angular velocity of the bar. We want to find out the angular velocity of the bar. For that we are substituting in this equation Vp equal to omega into IP. Vp value is already given. If you can identify the value of IP, or we can somehow find out the value of IP, then omega can be calculated. So considering this triangle using the trigonometry, we know that the length of the rod is given as 1 meter, that is PQ equal to 1 meter, and if you consider the cos of this angle 60, then cos 60 equal to adjacent by hypotenuse, that is IP by OP, that is IP by OP is 1. Cos 60 equal to IP by 1, so IP equal to cos 60 into 1, so you will get IP equal to 0.5. So instead of IP, I will substitute PQ into cos 60, that is 1 into 0.5. So finally you will get omega equal to 10 radian per second. Now our aim is to identify the velocity at point M. For that we will be considering this triangle, this small triangle IMP. M is the midpoint of this rod PQ. So the length from P to M is 0.5 meter. and from the trigonometric relation we can calculate the value of IP. I have already told the value of IP is 0.5. See, cos 60 equal to adjacent by hypotenuse, that is IP by OP. If you consider the larger triangle, then cos 60 equal to IP by OP. From that, OP is 1 meter, so IP equal to cos 60 into 1, that is cos 60 is 0.5. So this value also will be 0.5. This is 0.5, this is 0.5. Then you can see that if the two edges of a triangle are equal in length, then the angle made by those two equal edges with the other edge will be equal. So this angle will be equal to this, that's angle M is equal to angle I in this small triangle. So this angle is already given as 60, so these two are equal, means total angle M plus angle I is equal to 120 degree, 180 minus 60. So these two angles will be also equal to 60 degrees. So all the angles are equal, means this is a equilateral triangle, that means all the edges also will be equal. So this is 0.5, this is 0.5, so IM also should be 0.5. That is one way of identifying the value of IM. And another common method, general method used is, in all problem IMP will not be equal to IP. So in that case you have to go for this equation. This equation you might have studied in the +2 level and all. And the equation says, what equation says is, if you know the two edges of a triangle and the including angle between that known edges, then to find the third edge which is unknown, the equation used is the root of the edges, square of the edges of the known, sum of the square of the known edges, that is root of MP square plus PI square minus 2 into MP into PI into cos 60 of included angle. That was the general equation. Here MP is 0.5, this is also 0.5, and the angle between these two is 60 degree. If you want to find out the value of IM, then the equation for IM is equal to, that is unknown edge equal to root of 0.5 square, that is this edge square. So 0.5 square plus next edge square, that is 0.5 square, both are 0.5 square plus 0.5 square minus 2 into this edge, 0.5 into this edge, 0.5 into cos of angle between these two edges, that is 60 degree, cos 60. For example, if this is 2 and this is 3, then equation becomes IM equal to root of 2 square plus 3 square minus 2 into 3 into cos 60. That will be the equation. Similar way you can identify the third unknown edge. Anyway, you can go for anyone which is convenient for you. This equation is general equation, so it is important to by heart it. Just remember this equation, then it will be easy to calculate the third edge. So IM value you got it as 0.5 meter. From this equation you got IM equal to 0.5 meter. Now we know that VM equal to R omega. Omega is common for the entire road PQ. So omega you got it as 10 radian per second, and R is nothing but IM. The distance from the instantaneous center is the radius. So IM is R. So IM you got as 0.5. So VM equal to omega into IM, that is equal to 10 into 0.5, that is 5 meter per second. So, and also it is not asked in this question, but it will be interesting to note down the direction of this velocity VM. See, here the velocity at the end of the road VQ is vertical, here it is horizontal, but here it will be inclined to a particular angle to the road PQ. That angle we can identify easily, that is, we know that I is the instantaneous rotation and IM is the radius. So the linear velocity will be always tangential to the radius of the rotation. So the linear velocity VM should be perpendicular to this line IM. That means VM will be making an angle of 30 degree with this rod PQ. So see, you can see that within a rigid body, different points Q, M and P are having different velocity, and also the direction of the velocities are also different. This is the example for plane rotation. So you will be having some confusion how a particular body will have different velocities at different points, because in all the 4 modules we have covered in the earlier topics and all, we were considering all the points will have the same velocity, but here in the plane motion within a body, different points will be having different velocity. This is a best example to explain all these things. I think the concept of plane rotation is the plane motion is very much clear for you with this example. And where the value is velocity of the point M, midpoint M is 5 meter per second square. That's all about this problem. Now moving on to the next problem. This is very important problem. We will move on to the problem, that is, in the reciprocating engine mechanism shown in figure, the crank OI rotates at a uniform speed of 300 rpm. The length of crank connecting rod are 12 cm and 50 cm respectively. The length of crank is 12 centimeter and connecting rod is 50 centimeter. Find the angular velocity of the connecting rod AB and the velocity of piston when the crank makes an angle of 30 degree with horizontal. So this is the reciprocating mechanism. This one is the crank. I think you will be familiar with the working of the reciprocating mechanism. You might have studied in the basics of mechanical engineering. So this is the crank. This crank will be rotating about this fixed point O. Based on the movement of the crank, rotary movement of the crank, this is the connecting rod. AB is the connecting rod. Connecting rod will be making this piston. This block is the piston. The connecting rod is making the piston to move to and fro within this horizontal surface. So the motion of the crank is rotary motion, whereas the motion of the piston is sliding motion. Okay, so that is what is the function of the connecting rod is to convert the rotary motion given by the crank into sliding motion to the piston. That is what is happening. So here you can see OA is the crank. This is 12 centimeter. This one is connecting rod is 50 centimeter. Dimensions are given, and we want to find the velocity, angular velocity of this rod AB or connecting rod. That is what is we want to find out. First, we want to find out the angular velocity of the connecting rod AB, the velocity of the piston when the crank makes an angle of 30 degree with the horizontal, and also we want to find out the velocity of the piston. This is the piston. VB and omega AB are the quantities that we want to identify, and at what instant we want to find is when the crank is making an angle of 30 degree. At that instant we have to find out all these quantities. So this angle is given as 30 degree. And now from the geometry we can see that if you consider a triangle, OBI, this is a right triangle. OB is parallel to horizontal line. So OBI is a right triangle. This is 90 degree. OBI is right triangle. Now this is given as 30 degree, and if you take this small angle as phi, we can apply the sine rule here. From the sine rule what we will get is OA divided by sine of angle made by the other two edges are phi. So OA by sine phi equal to AB by sine 30. That is the general equation. So OA is known, but sine phi value is not known. AB is known, 30 is known. So from this equation we can calculate the value of phi. So here that equation is given. This equation is OA by sine phi equal to AB by sine 30. That was the general equation. That is application of the sine rule. From that you will get sine phi equal to OA by AB into sine 30. Now substituting, you will get phi equal to 6.89 degree. This small angle is 6.89 degree. This remaining angle is 90 degree. So this is 6 point something. So 90 minus will be the remaining angle. So this angle is 83.11 degree. 90 minus 6.89 degree. That is this value. Now since this is 30, this is 90, this one will be 60. So since it is 60, this is 60, this is 83.11. If you talk about the small angle, small triangle ABI, from this triangle total angle will be 180 degrees. So 60 plus this one, 180 minus 60 plus this one will be this angle A. So angle A you will get as 36.89 degree. Now we want to identify the instantaneous center. Here the difference from the all other problems that we have solved earlier are, here two links are there. See, OA is a separate link and AB is another link, and it is joined at the point A. So we have to think about the two links. But in our problem we have to identify the angular velocity of this link only. AB, angular velocity of the link AB we have to identify. But sometimes we have to think about this link OA also. See, this link OA is purely rotating about the center always. So as far as this fixed point and this link is considered, the instantaneous center of rotation of this crank is at this point O. So if you are talking about the rotation of the crank, then you have to consider radius as this much value. But you can see that the rod AB is actually rotating about this instantaneous center I. So if you are considering the rod AB, then at point A the radius will be IA, corresponding to point B the radius of rotation will be IB. See, for this point A you are getting two radius. One is the radius corresponding to the rotation of this rod AB about instantaneous center. So at that time the radius you have to take it as IA, and if you are talking about the rod rotating about this instantaneous center O, then at that time radius should be this distance, that is OA. So correspondingly you will get two different values for the velocity at A. But if you find out the velocity of linear velocity of A by two different methods, the final value will be same only. Okay, there won't be any difference. Or sometimes we can equate this equation also. That is what we are doing in this problem. Okay, anyway, our first aim is to identify the instantaneous center. We have identified the angles and all. Now we will move on to we will try to locate the instantaneous center. So to locate the instantaneous center, what we need is, at least we should know the two velocity direction of the two velocity. So first think about the velocity of the point B. See, this actually B is in the piston, so point B is within the piston. So piston will be always moving to and fro along the horizontal direction. So since crank is rotating in this direction, anti-clockwise direction, that means possibility of piston to move is towards the left side. So VB will be always horizontally in this direction. So direction of VB is horizontally in this direction. So to identify the instantaneous center, I will be drawing a perpendicular line to this direction of VB. So that is this vertical line. So in this line, the instantaneous center I will be there. Now one more velocity direction we have to identify. For that I am taking velocity of the point A. See, first consider this link OA. So actually A will be moving along the circumference of this circle. So at every point, the linear velocity of the point A will be tangential to this circle, since it is moving along a circle. So VA will be always tangential to this circle. So if VA is tangential to the circle, then if you draw a perpendicular to the tangent, then that line will be always passing through the center of the circle. So VA is in this direction, tangential to the circle, and the perpendicular to that tangential will be always passing through the center OA. So OA will be the perpendicular line to this velocity vector VA. So that extended will meet at this point, that is the instantaneous center. So that is the method of locating the instantaneous center. Now we got the instantaneous center. Now our aim is to identify the angular velocity of the link AB. For that I have identified angle and all. This I got as 36.89 degree. Everything I have obtained from the calculation and all. Now I want to find out the value of this one, BI. I want to find out. Also I want the distance AI. The quantities I had to find out are the angular velocity of the connecting rod AB and the velocity of the piston when the crank makes an angle of 30. Velocity of the piston, I want to find out the velocity of the piston, that is VB. VB I want to find out, and also I want to calculate the angular velocity of the rod AB. For that I have to find out the distance IB and IA. For that I am using sine rule for this small triangle, that is IBA. Within this triangle I am applying the sine rule, that means AB, this is AB, AB by sine 60 equal to BI, BI by sine 36.89 equal to AI by sine 83.11. That is the general equation. Out of that equation, AB value is known. So AB by sine 60, this entire value is known. So I will be comparing this one with the first one. So BI equal to AB by AB into sine 36.89 divided by sine 60. So you will get BI equal to 34.66 centimeter. Remember, all these values are in centimeter. If you calculate the velocity, you have to convert it into meter. So similarly, AI, taking these two relations, AB by sine 60 equal to AI by sine 83.11. From this you will get AB into sine 83.11 divided by sine 60 equal to AI. So AI value you got as 57.32 centimeter. Now the crank rotation speed is given as n is equal to 300 rpm. From that we can calculate omega of this link OA. So omega OA equal to 2 pi n by 60, 2 pi into 300 by 60 equal to 31.4 radian per second. Now as I told, I have two equations for the velocity vector at a VA. One equation is based on the rotation of this link OA and about this point O, and the other equation is based on the rotation of this AB, link AB about instantaneous center I. So the first equation is about the instantaneous center I. If AB is rotating, then the velocity of the point A is VA equal to R omega. Omega means omega of this rod AB. Since AB is rotating about instantaneous center, so omega AB into AI. Radius is AI. That is one equation for the linear velocity of VA. VA equal to omega AB into IA. See, this in this case AB is the considering link, and this link is purely rotating about the instantaneous center I, that is the meaning of instantaneous center, and Ia is the radius of rotation. So Va equal to omega AB. See, remember, omega AB is not equal to omega OA. Omega OA is different, omega AB is different, since these are two links. In all the problems that we have considered early, only we are considering one link, so all the point will have the same omega, but here different links are considered simultaneously, so link will be having different omega. So omega AB will not be equal to omega OA. Remember that thing. So first equation about the instantaneous center I got as Va equal to omega AB into AI. Similarly, Va, I can write one more equation considering the motion of the crank OA, that is Va equal to omega OA into OA. OA is the center of rotation. OA is the center of rotation. OA is the radius. So the second equation is very much familiar. Va equal to omega OA. Omega OA value is given as 31.4 radian per second. That is known for us. Into OA. OA is the radius. That is 12 centimeter. That is equal to 0.12 meter. So substituting, you will get Va equal to 3.77 meter per second. Now we got the value of Va. Now we can substitute that Va value here. Va equal to omega AB into AI. AI value already we got here. So substituting all these things, you will get omega AB. Omega AB equal to 3.77 divided by 0.57, actually 57.32 centimeter. Converting into meter, it becomes 0.5732. So omega AB equal to 6.58 radian per second. Now we got the angular velocity of the link AB. That was the first question. Now second one is to identify the velocity of Vb. We know that Vb is equal to omega AB into IB. That is the equation. V is equal to R omega. Omega is the omega of link AB. AB is rotating about instantaneous center. So Va equal to omega into Ba, that is equal to 6.58 into IB value is 0.34 meter. So you get as 2.28 meter per second. So I think this problem is very much important one. In your syllabus and all, it is given that just to concept only we had to study about the instantaneous center. But for the last exam, I think university has asked a problem from this topic. So you can expect a problem from this topic in this exam also, and it is going to be much difficult problem also. So it is very important to go through these type of problems while studying the topic. Okay, all the best.